good morning or good day or good evening, depending on your time zone. Welcome to Teltonika webinar, Telematics for Agriculture, Guide to Field Machinery Data Reading. My name is Ksenia Dolya. I will be your host today. Today, I have amazing experts that will help me to explore the topic. So our main speaker today is Margarita Smolenska. She's operational marketing coordinator at Teltonika. She is behind all our communication around professional devices. So in case you're reading our blog, you definitely read some of her articles there, that's for sure. And Margarita would be our main speaker today. But that's not all. Behind the scenes, we have Donatas Andriulionis, who is the project coordinator for our professional devices program. So he is the biggest expert in how it actually works. And also we have Vivek from our IoT engineers team. So he is 6 years with the Teltonika and has very good experience with everything related to CAN reading. So Donatas and Vivek will be answering your questions in Q&A during the session. So yeah, feel free to use the opportunity. So without further ado, let's dive into the industry of precise agriculture. So first of all, why we're speaking about agricultural industry today? Well, because the industry analytics value global precision farming market at 15 billion USD globally in 2025. The industry size and the level of digitalization will be different from region to region, from country to country. And I'm sure, dear viewers, you can share in the chat how it is in your country. But the global trend allows us to see where the industry is actually moving. The investment in precision farming has multiple directions. It's inventory management at the warehouse. It's, of course, irrigation management and weather forecasting. That's especially important in the context of climate change and the heat waves that we are experiencing right now. It's, of course, labor management, like tracking the location of your field workers, for example. It's, of course, crops counting, because genetics of the crops is highly important both for yield and also for compliance with local regulation. It's also field mapping. So the industry uses satellite mapping for optimal result. Also, there is an emerging industry of yield prediction with big data and overall data analytics with machine learning. However, the majority of the investment, 43% of market valuation, goes into yield monitoring. No matter how important the fleet maintenance and fuel consumption is for the agricultural business, the ultimate marker of success for the business would be growing the yield. So how much produce was collected? We see how it was in previous years, how it compares with the amount of crops planted, with the amount of fertilizer applied, and so on and so on. So actually my first job was the internship at the economics department of the local farm. And at the time, I still remember that yield monitoring was mostly guesswork, because at the time the company was using paper journals. The workers needed to fill in the actually paper documents that we were processing. And if I wanted to check the reality of the situation, I needed to actually go to the field. So that's not how it is right now, of course, because the industry is evolving. Today, agricultural business looks completely differently. So yeah, this is an example for you. Today, the field machinery we're talking about, it includes not only the tractor with implements. We're talking about high-tech digital systems that allow to measure exactly what jobs were performed, and they allow to create a very precise track using RTK antenna. So today we will talk about it as well. And the amount of data is surely way higher compared to how it was before. However, there is another side of that. It creates operational complexity. It's complicated for the manager to sync and process all the amounts of data, and on top of that, there is a gap that happens in the field. You can plan the jobs, but also it's this guy on the picture, this field employee, that will implement it. And the gap between plan and execution, it happens not because of bad faith. Well, sometimes it is the case, but not specifically. It's the complexity of operations, it's disconnect between the head office and the field, it's insufficient remuneration, why not? And many other factors impact it as well. So telematics can bridge this gap and help both the manager in the office and the worker to perform field operations successfully. Today we will discuss how, with the help of telematics, we can actually ensure that agronomic plan is carried out exactly as it was planned by the company. So, and I'm passing the word to my colleague Margarita that will talk about the solution Teltonika can offer to agricultural businesses.
Thank you, Ksenia. It is true that farmers want to boost field yields, and therefore the first solution that they look for is to find solutions that can diagnose the health of crops, check whether inputs were applied correctly, and which areas may require additional attention. And we commonly in the industry refer to it as field mapping. I actually see a lot of these demands for soil heat maps reflected in communication of leading agricultural management platforms. You open a landing page and immediately see solutions for catching soil problems with data from in-field sensors, drones, and satellite images. But for agricultural solutions, that's barely a beginning. To ensure that investment in the heat map pays out for farmers, companies need to track exactly how machinery moves across the field. And for that, of course, we need a cornerstone of IoT to get it right, which is providing accurate tracking. This is a point at which a lot of problems start to appear for agricultural fleets, because it's quite difficult to find a device that would be able to provide a high-quality track at the low speeds of the tractor. As we know, tractors are making sharp turns at the low speed, so there are a lot of deviations in the track and jumps. But that's not all that we need to ensure for a proper solution. Beyond just where the tractor goes, a smart platform must monitor how the tractor performs. Because during the operation, a lot of things can go wrong, like tractor overheating, fuel theft, or plow getting damaged with stones. That's why tapping into tractor control systems is the must for farmers to confirm that machinery is performing optimally without being pushed past its safe operational limits, preventing costly wear and tear. And finally, farmers look for an ability to pinpoint and check how much materials was applied in the field. For that, agricultural platforms need data from spreaders, like working status with content application rate, to actually compare the agronomic plan and what happened in the field. So where do you get all of this data? Today, we're going to look at how three critical pillars of agriculture, accurate position, tractor, and implement data, all seamlessly connects through a single universal standard, ISOBUS. So, what is ISOBUS? When we think about a tractor, it really consists of two main parts: the tractor itself and the attached implement, which is a specific piece of equipment that actually works the field. Now, there are hundreds of different types of implements and also brands of implements. So to get them to talk to each other, a standardized communication protocol was introduced in 1991. This allowed a seamless data exchange between tractors and implements regardless of the trend. A key element of this ISOBUS network is a control panel inside the driver's cabin. Through the terminal, the driver can send commands to control the implement, so to command like to lower it or to raise it up. But it's more than just manual control of the implement. A farm operator can actually upload a digital map of the field directly into the system of the tractor. This allows the driver to see the precise application targets and navigate the field in real time, tracking exactly where they've already been and where the product has been applied. In real life, however, the access to ISOBUS data is often paywalled by the original manufacturers. And this creates a very interesting paradox. Tractor operator sees a very precise track in real time, controlling application volume and seeing application track on the screen in his tractor, while farm managers either get access to basic data from trackers that were only meant to be used on the road, or they pay thousands in subscription costs to get this data from original manufacturers through APIs. And we get it. Telematic integrators want the best for their clients, so meddling with the tractors can usually lead to losing the warranty. Therefore, a common solution is just to pool a couple of APIs and pay for this data. However, it increases the end cost of the solution and also locks the farmers to using one brand of equipment. So, is there a better way to read agricultural data? Well, Teltonika professional product team worked very hard on a new extended ISOBUS functionality of FMC650 trackers to collect tractor and implement data from onboard systems. With instant and warranty-friendly connection to the tractor's diagnostic socket, it provides information about precise location, tractor system data, and implement real-time performance. Is it really a plug-and-play installation? Yes, you heard that right. To get ISOBUS data from the tractor, there is no need to cut wires and compromise warranty. See, just like any vehicles, tractors are equipped with a diagnostic socket, which is used by mechanics at the repair shop to quickly identify vehicle faults. So, with us, you can acquire a 9-pin cable from Teltonika and connect sometimes the scary 20 pins to the 9 pins, and power the device and read the ISOBUS data at the same time. Nice! Now that we know how FMC650 reads ISOBUS data, let's talk about the exact parameters and solutions you can build with them, starting with movement data. Many commercial farms invest in RTK antennas because they need tractors to navigate fields with centimetre-level accuracy. This precision minimizes overlaps and gaps between passes, preventing the over-application of seeds, fertilizer, and crop protection of products. Over-application not only wastes the products, which are very expensive, but also can damage the crop through excessive chemical or fertilizer application, reducing overall efficiency and ultimately lowering the yield. So, how does RTK antenna achieve such high position accuracy? In short, RTK improves standard GNSS by correcting the coordinates from the GNSS signal. So, what errors are there? Well, on its own, a standard GNSS receiver typically provides accuracy of around 1 to 3 meters under good conditions, because satellites are moving relative to the Earth and the signal itself has to travel through the atmosphere. Then both the tractor and the satellites are constantly moving. So it's very natural that small errors occur during this process. That's why RTK base is installed on the field and it's constantly corrects the errors, allowing the tractor to receive a centimetre-level accuracy of track. There are also two types of RTK antennas that farmers usually invest in. It's either a solution provided by a regional manufacturer that is installed directly into the tractor, or it can be equipped in the aftermarket, which is also very commonly bundled with auto steering and navigation screen services. The advantage of FMC650 is that you can read both factory installed and retrofitted RTK systems. So, how do you actually read the data? FMC650 will always prioritize RTK signal over the GNSS whenever it's located in the vicinity. So we have two ways of reading the data. First and the easiest method is reading RTK from CAN. The collected coordinates from CAN includes latitude, longitude, altitude, speed, and angle. This data is available through ISOBUS because, as I already mentioned, the control panel has, because of the control panel that's already equipped in the CAMIT. So as you can see in this screenshot that I found from American vloggers, and a lot of end users are actually doing a lot of tutorials about how to drive a tractor and how to install these RTK antennas. So they provided a very good example of how the RTK looks from the inside. You can see that the tractor right now is at the edge of the field, which is outlined in pink. On the left side, we can see the spreader, that the spreader needs to be a little bit higher in order not to damage the part of equipment. Then on the right side, you can see an application trace in blue, which means that in order to avoid over application of crops, this right side of the implement has to be turned off. So this data is already in the tractor system and it's already in the ISOBUS. And that's exactly how we get it, because we also connect to the ISOBUS system. Now, there is a second way to read RTK data, which is RS232. In addition to precise location, you can also get a quality of the GPS fix. For example, you can see if the correction by the RTK was done using satellite images or estimated with inertial sensors. This information is usually helpful for diagnostics, logging, and in overall verifying that the external RTK receiver is working properly. And of course, we would not create this webinar unless we tested this functionality in real life. So, on the right, you can see FMC650 results paired with RTK data from CAN. And on the left, you can see the results from tracking with a regular FMB tracker. And I think the difference is staggering, because in the one track you can see jumps, you can see knots where there were sharp turns, whereas with FMC650 the track is not just beautiful but can empower decision making when combined with the soil heat maps. However, sometimes it happens that tractors don't have an RTK antenna equipped. Does it mean FMC650 is not well suited for agriculture? Not really. We made some very conscious decisions to improve accuracy of tracking at the low speeds. First of all, FMC650 features an external GNSS and cellular antennas, which gives you an ability to install it in places with minimal signal interference, like the roof, for example. Secondly, it is equipped with L1 and L5 improved GNSS module, which means there are more satellite frequency the tracker can pick up on. Finally, the device enters a slow-moving mode to improve accuracy of the track when the speed of the vehicle is lower than 10 km/h. So this is our solution for accurate tracking. But now I want to ask you, what operation was done here? Was the tractor mowing the field? Or maybe it was spreading the seeds? Maybe it applied water? Only tracking location, even if it's accurate, won't tell you much. Therefore, agricultural telematics solutions should also provide fieldwork data. There are roughly 3 main operations in the fields that I could identify. Operations preparing the field usually include tillage of soil, mowing the grass, and using loader attachment of the tractor to move soil, gravel, stalls, and even trees. Then, for growing crops, tractors are attaching sprayer and seeder implements to distribute materials throughout the field. And finally, collecting the yield operations include harvester and harvest handover aspects. So let's see what kind of data you can get from each of those. There are different types of implements that are used for preparing the field: plows, versatile loaders, harrows, and tillers. What do they all have in common is that the implement itself is not applying anything, and it's rather operated by the tractor system. So the data about its performance is located in the power transmission system of the tractor. It includes hitch, hydraulics, and PTO parameters. Let's look at each of them. Starting with hitch. Hitch is the part of the tractor that attaches the implement. In the picture, you can see the most common type of the hitch, which is a 3-point hitch. Modern hitches are hydraulic and equipped with sensors to monitor their position. So what exact parameters can you get with FMC650? In work indication does exactly what it sounds like. Indicates if the implement is working. And for you it's useful because it can automate workflows records. Next, we read the exact position of the hitch, if it's raised, lowered, or in between. It helps prevent uneven tillage or planting by detecting when the implement is working too shallow or too deep. And in overall, when we think about tillaging operations, the pulling motions put some stress on the implement and force. This resistance from soil is measured by draft and nominal lower link forces. What's the difference? Draft measures the horizontal pulling force, while nominal lower link indicates how heavily is the hitch loaded. Monitoring those can give you a lot of insights into the soil itself. For example, the draft source of normal soil is around 40 kilonewtons. So, if there is a sudden spike to more than 100 kilonewtons, you can understand that maybe the plow is trapped in stones, and that's why the resistance is so high. Thus, the operator can dispatch someone to check and clean the spot, or lower the speed limit in the geozone in overall if it's a rocky landscape in overall. Next, we have hydraulic system of the tractor. Precise control over hydraulic movement is vital, especially in precision farming. For example, the extend retract ports flows determine how smoothly a boom or a sprayer extends and how quickly a loader arm lifts. Monitoring this data allows operators to prevent damage and adjust settings in real time for optimal performance. With the FMC650, you can read hydraulic pressure and flow rates in the auxiliary valves, which control the movement and operation of the attached equipment, as well as flow rates for both extending operations, which means pushing out the implement, and retracting, pulling in of the hydraulic cylinder. So, as an example, a system flags a low valve flow. What could it mean? We can wait for a tractor to return to the depot and check if the pump is blocked or it needs replacement. Then we see a small but vital component in the picture: PTO. Power takeoff system transfers mechanical power from the tractor to the implement, typically driving equipment such as bowlers, sprayers, and mowers. We capture the speed and power output of the PTO, ensuring that the implement is operating within its specified range. It matters because if the PTO is running too fast or too slow, it can lead to poor implement performance or even damage. And in field operations, every day counts. So a non-working PTO can cause implements slipping under the load and thus not properly working. So by monitoring PTO data, farmers can ensure that machinery operates under optimal conditions and can work when you need. I also want to get your attention to the socket right here. This is a 9-pin socket, but the one that is used for connecting the implement to the tractor. Through there flows communication between the equipment using ISOBUS protocol. Each command in the protocol has its name or a unique DDI value, which is a key to our next session on growing crops. Growing crops. What do we need to do? Water, protecting the plants with chemicals, applying seeds and fertilizers is all usually done by sprayers and seeding attachments. This kind of implements are equipped with many sensors and contain a wealth of data themselves. So, what DDIs can you read with FMC650? First, we can monitor implement status in real time. Main parameters here are work status, park, and transport. This information is really useful for resolving situations when the implement was damaged. Imagine, a driver by accident forgot to retract the wings of the sprayer. So he goes up the road with a high speed and suddenly, boom, damage. With implement status, operators can have a solid proof of who was at fault in these situations and avoid paying for damage out of pocket. Finally, arguably, the most important data for precision agriculture is amount of seed, fertilizer, and chemical applied per unit area because it tells you whether you're applying the right amount of product in the right area. With FMC650 trackers, we can compare the planned application rate with the actual one. If there is a difference, operators can immediately see that the implement is not performing as expected, maybe because of calibration issues, blockages, or changing field conditions. We also monitor the planned and actual volume applied, which helps understand exactly how much seed fertilizers was used during the operation. Another useful parameter is the working length. Combined with RTK data, just like we saw in the screen earlier, it allows to calculate the treated or harvested area and understand how much work was actually completed. I want to stress that these parameters is not simply impressive. Implement data is a cornerstone to verify that field operations were performed according to the plan and get a much clearer picture of input cost per field. Ultimately, without this data, the investment that went into field mapping is not paid off. So, let's collect it all together. With one device, you can read RTK, tractor systems, and implement data. FMC650 collects all of this information by connecting to the ISOBUS network through the diagnostic socket of the tractor, and all of this process is transmitted to a fleet management platform. A fleet manager then can analyze number of materials applied using a highly precision track combined with working width of the implement and output of content. Indicators like PTO, hydraulics, and hitch in turn can help proactively repair equipment and automate logging of the working hours. Combined all together, you can create a powerful telematics system for fieldwork monitoring and confidently enter the precision agriculture market. Because this telematic setup brings value in the areas that farmers mostly care about. So, you can help identify profitable fields, machinery, and drivers. You can monitor that the right volume of pesticides and seed is applied so that the soil stays fertile and can bring money the next year. And of course, to stay compliant with national regulations by having a proof of how much chemical was applied. And it's only 50% of the solution that you can create with FMC650, because it is still a standard telematic device. So while purchasing telematic data from the manufacturer of the tractor seems like an easier way, integrators would be missing out on solving problems that arise outside of the field and with other machinery that is present at the agricultural depot. And the need for a device that can see other machinery working alongside the tractor is really clear when we are talking about collecting the yield. So, in order to safely hand over the harvest, the farmers need to confirm that the truck was working alongside the tractor at the right time and place. For that, you can install FMC650 in the truck and monitor trailer weight and axle load in the real time. In that way, there is no need to dedicate additional development time to integrate a new device on the platform, while also solving twice the problems. At first, the tracker helps to see how much grain was collected, and then you are making sure that none of the grain was stolen by the time truck arrives to the silo. Also, sometimes farmers can ask to oversee very specific implements or tractors. For example, someone might come and request to track a potato conveyor speed. And the good news is that you can read this data without waiting for our team to add this parameter to the firmware. With manual CAN requests and commands, you can read up to 70 unique parameters and 10 commands as long as you have the protocol of the vehicle. Naturally, if our team sees that a lot of firmware requests come for popular DDIs, we will continue advancing this functionality and then later add them to the firmware. Of course, reading data is not the only thing that telematics can do. Thanks to multiple inputs and outputs, one wire, RS232 and RS485 serial ports, you can connect additional equipment like fuel level sensors to react to siphoning quicker, RFID cards to make sure that only company employees can drive the tractor. And you can expand visibility to non-motorized assets using Teltonika eye beacons. For example, a lot of operations in the field require to switch attachments multiple times per day. So it gets pretty easy to forget it in the field. With beacons, you can create an ID for each implement, see when it was coupled with the tractor, and then quickly identify the last location it was seen in the field. Finally, for farmers, maintenance of equipment is just an additional headache to remember about. They really want to think about maximizing the crop, but instead, they need to send a tractor to a workshop every time something sounds suspicious near the PTO. And suddenly they need to pay for a whole repair because some irreversible damage was done. To prevent that, you can automate maintenance with DTC codes. FMC650 can read currently active and previously active codes. Tractor start to notice internal abnormalities and generate codes even before a check engine light appears on the dashboard. So in this way, instead of reacting to the damage mid-operation, agri-fleet managers can look for equipment parts in advance. So, beyond precision agriculture, FMC650 also lets you help your fleet customers run a tighter operations overall. Lower fuel spend, faster reaction to fuel theft, and quicker detection of equipment damage. Combine that with DTC codes, and you can offer an automated maintenance workflow for both tractor and trucks. Installation stays straightforward on your end as well, because we are using a 9-pin cable, which is quick and easy to install. And at the same time, the tracker can be used for the trucks on site. So, I encourage you to use Pro devices to bring agricultural fleet management to the next level. Thank you for your attention, and I give mic back to Ksenia.
Thank you so much for your active participation. And yeah, I wish you a great time and see you at the future webinars.